everyone. So today we're demonstrating a model of how rivers or streams flow in areas that are paved like urban areas and areas that are vegetated like rural areas. So come closer to the station to see. So this represents a paved urban surface. The clear sheet shows that it's made up of concrete. And we have some sediments here. We're gonna pour water down here to show how water flows through here. But this cloth represents vegetation like plants and trees. We're also gonna compare this to see how water flows. So the first thing we're gonna do is grab some water. And we're gonna pour it at the same time. So this is rural and this is urban. And let's see what happens. So notice that the water flows a lot faster in the urban surface compared to the rural surface. The rural surface, especially this cloth right here that represents vegetation, is absorbing a lot of the water. And this happens in real life as well. If you have lots of plants and lots of vegetation, it's actually better for water to infiltrate into the ground or go into the deeper into the ground compared to places that are paved like concrete that prevents that infiltration and creates more runoff. So in places like New York City, which is an urban surface, we have a huge problem with flooding because a lot of our surfaces are paved and the water normally flows or runs off the surface instead of flowing into the ground. A solution that we're trying to come up with for flooding in a lot of these areas is creating rain gardens, which are designed by humans to help, or plots of land designed by humans to help the water infiltrate more into the ground. For those rain gardens, we normally have lots of vegetation like this cloth represents, but we also have a certain type of arrangement of sediments that we use in our rain gardens. So if you come here, you can see two different types of arrangements. We have sorted sediments or a sorted arrangement that has layers of different types of sediments of different sizes and shapes, and they're not mixed together. We also have unsorted sediments. That just means that the layers are all the sediments are mixed up in a random order. So we're gonna pour water through both of these and see which one will flood more in the top and which one will have more infiltration, more water going through the ground. The one that has more water going through the ground or infiltration will be better for our rain garden because we want to prevent flooding. We want more water to go into the ground. So we're gonna try that again. I'm gonna pour some water into these cups. And let's see what happens. Okay, so it might take a little bit of time, but we're looking for how we're comparing the time it takes for water to drip down over here. And so you can already see that the water is dripping down a little faster in the sorted sediments than the unsorted sediments. Normally in rain gardens, we want sorted sediments. We want the sediments to be in layers so that the water drips down faster over here. Eventually it will drip down a bit more faster, but right now it's taking its time going through. Unsorted sediments, if you look at the top, it's way more flooded when we have unsorted sediments. We want the sorted sediments, or we want the sediments to be in layers so that we have less flooding and more infiltration. Another thing I want to show that in New York State, a lot of our land is made up of limestone, which is made up of a mineral called calcite, and that's a huge problem for us. This is calcite. It's a mineral that creates limestone, and a lot of our New York State the land in New York State is made up of that. We're also dealing with lots of acid rain throughout the world, and I want to show you what happens to limestone or calcite when it reacts with acid rain. So I'm going to take this tablet, Alka-Seltzer tablet. We're going to pretend that this vinegar is acid rain, and we're going to see what happens to calcite. We're pretending this is calcite or limestone, and what will happen to it if it comes in contact with acid rain. So if I drop this here, you can zoom in from the top. Notice that we start seeing fizzing and bubbling. I'm going to add a bit more of the vinegar to show this. So it starts to fizz, and it will eventually break down. You can show from the side as well. Eventually, the seltzer or Alka-Seltzer will break down completely because of this chemical reaction that's going on between the acid and the Alka-Seltzer, in this case, acid rain and limestone. So because we have so much acid rain now throughout the world, it's affecting our landscapes in New York State, and it's forming these caves and these sinkholes because the acid from the acid rain is completely dissolving the limestone, just like you see here. You can see then from the top that it's completely bubbling. I think that is it for now. I'll see you next time. Bye.